Hello, good morning students. So welcome to my whiteboard program. Today we will discuss chapter 11 class 9 science work and energy second part. Last class we have done up to mechanical energy. Mechanical energy two type. That is one is known as the potential energy PE is equal to mgh and kinetic energy is equal to half mv square. So today we have to discuss the derivation, the mathematical expression of kinetic energy and potential energy, and the mathematical derivation of that is called the law of conservation of energy. These three are important today. So let us come to the board. Here you see it is given derivation of kinetic energy of a body. So what is kinetic energy? I have told you what is kinetic energy. Kinetic energy is the energy possessed by a moving body or body in motion. The body which is moving. Last class I told you the fan which is rotating on the roof, that has the kinetic energy. The fan which is standing silently, that has the potential energy. So we have to derive mathematically how half mv square is coming kinetic energy. Let us see. Let an object of mass m moving with initial velocity u due to the application of a force F causes a displacement s and the work done is w with producing an acceleration a. Suppose a body in the rest starting to move with initial velocity u and body mass is equal to m, the force applied is equal to F, the distance covered is equal to s, and the work done for that is w, and the acceleration produced is a. All this we have to write down first. This is I have written. Then we have to start. We will derive this mathematical expression from the third law of motion. Motion there are three laws. So first law, second law, third law. We are taking the help of the second law. From the third law. From third equation of motion, we have 2as is equal to v square minus u square. Just recall the equation of motion. First is known as the v is equal to u plus at. Then second is equal to s is equal to ud plus half at square. And third is v2as is equal to v square minus u square. That we are taking. Now from this formula, s you keep. I have kept here s equal to v square minus u square. This 2a will be divided by side change. So v square minus u square by 2a. Point number 1. We also know force is equal to mass into acceleration. So mass is equal to m and acceleration is equal to a. So that we know before F is equal to ma. That is point number 2. Now work done we know also. W, work done is known as the W is equal to F into S, force into displacement. So let us, W is equal to force, we are taking the help of, that is point number 2, force is equal to MA into S from point number 1, S is equal to V square minus U square by 2A. So from point number 1 and 2, we are just substituting the value. F is equal to MA, S is equal to V square minus U square by 2A. So W equal to a cancel, then downside 2 is there, we can take as 1 by 2, m is there, m v square minus u square, then w is equal to 1 by 2 m v square minus u square is equal to 0 here because the body starts from the rest. When the body starts from the rest, the initial velocity always 0, so that's why v square minus 0. So w is equal to 1 by 2 m, only v square is left, so w is equal to 1 by 2 mv square. We know work done is equal to energy because before that last class I have told you w is equal to E. Energy is also considered as the work. So work done is equal to energy. So w is equal to energy is equal to kinetic energy because body now in the motion equal to half mv square. So kinetic energy of a body depends upon two factors, that is one is known as the mass and second one is known as the velocity of the body. So this is about the derivation of kinetic energy of a body, that is Ke is equal to half mv square. Let us come again potential energy of a body. Potential energy of a body means the energy possessed by a rest body. When a body is rest, suppose you see, this is the blackboard, this is in the rest, this is the balloon, this is in the rest, this is the stick, this is in the rest. So all these have the energy, but what type of energy? Potential energy. Potential energy also we have to derive how it is coming, mgh. So potential energy of a body, energy possessed by a body in rest, that is potential energy is equal to mgh, also known as gravitational potential energy. Now when the body will be taken upside, now but it will be kept here, then the body will be taken upside, that is going against the gravity. So the work is done, or the energy produced by this body, that is called the gravitational potential energy. So because the force is applied by the gravity here, so that type of potential energy is known as the gravitational potential energy. Let a body of mass m is at a height of h from the ground. Suppose a body is mass m and it is height from the ground is height is h. Then the force applied is equal to m into a, because we know F is equal to ma. So here force required is equal to m into a. But here we do not write a because this is the gravitational force. So due to gravitational force, the acceleration is caused, taken as the g, small g, that is the acceleration due to gravity. So force required F is equal to ma, but it will be written as mg, where g is the acceleration due to gravity. Now force F equal to mg, then work done we know W is equal to F into S. So we are writing F into S. So that F we are writing now mg, and S is here h, matlab height. That means height. So when the object is taken from the ground up to some distance, that is called the height, that called the h. So this mgh. So here the distance, here the distance means the height of the object from the ground. Now W is equal to, that is energy, that is equal to mgh. So potential energy is equal to mgh. Now we'll come to the third, that is called the law of conservation of energy derivation. Law of conservation of energy. Here it is, you can see law of conservation of energy, that is derivation. So we have to see what is law of conservation of energy. You can go through. Law of conservation of energy states that energy cannot be created or destroyed. It may transfer from one form to another form. So this is the law of conservation of energy. So now let us see how it is. That means what? That means neither can be created nor be destroyed, but it remains same, it remains constant. At any point of an object, the total energy, that is kinetic energy and potential energy, will remain constant. That we have to show. That is, suppose a body from here, that is from the ground, is taken up to here, that is height is equal to h distance. So here the body is positioned at the rest, the body is known as the A. So let us see what is the energy here, what is the energy here, and what is the energy here. So let a body mass m at a height of h is positioned at A. Here v is equal to 0. Why v is equal to 0? Because v is known as the final velocity. When it moves, then its final velocity. But now as it is rest, that is u is equal to initial velocity, v is equal to final velocity. Here the final velocity is equal to 0. So now at position A, potential energy is equal to mgh, because mass is there, acceleration due to gravity is there, and height h is there. That's why potential energy of the rest body will be mgh. But the kinetic energy will be 0, because here the velocity is 0, because rest body. So kinetic energy formula is equal to half mv square. V is equal to 0. That means kinetic energy in this position is equal to 0. So total energy at the A of the body is equal to mgh plus kinetic energy, that is kinetic energy 0. So mgh plus 0 is equal to mgh. So in this position, total energy will be mgh. Let us go to the body falls and reach at B. Suppose now body is falling down, and at B we have to consider the total amount of energy. So as there the potential gets decreased and the kinetic energy get increased. Why? Because here it was rest. So potential energy was maximum and kinetic energy was 0. But when it will move here, the potential energy slowly goes down and kinetic energy will slowly rise up, because the velocity will be get more and more the velocity, more the kinetic energy. So when this body will come up to this position, C position, just before touching to the ground, we take here height is equal to negligible, that is 0. In this condition, we have to see what will be the total energy. Let us see. When it will touch to the ground, H is equal to 0. Now potential energy is equal to minimum, because here the potential energy, because it is not coming to the rest, velocity is high here, so the kinetic energy will be maximum, potential energy will be minimum. So maximum total energy is here constant. Whatever energy was here, now here the energy will be same. So that's why the total energy here, how much? The total energy here also that much, but only it was converted into one form to another form, that is potential energy to kinetic energy, but the amount of energy remain total same. So that says that at any point of an object, the total amount of energy remain constant. So this is your law of conservation of energy, derivation. So this much today, and coming class we will go for other parts of this topic. So you have to wait, just practice this one and make yourself ready for the coming class. Till that, goodbye.